So hi, hello, and welcome again. Microbehunter here. I'm Oliver, and today I would like to show you, I think, what I consider an interesting phenomenon, one that has already been discovered back in the 19th century, and it's called the formation of aerotactic bands. And I know it sounds very fancy, so that's why I decided to show this to you directly here. Under the microscope, I put a water sample, and what you see over here is you see those green half-moon-shaped structures here. These are algae, and those tiny little things swimming around here, these are on the outside, these are bacteria. And something that you can observe quite often is that those bacteria, they don't like to touch those algae, so they keep a safe distance here, and very often you actually see them form some kind of a line around those algae, and that's referred to as an aerotactic band. And as a matter of fact, this is a very common observation, even if there are no algae present. And I would like to show that to you. And what I've done is I've made a time-lapse video of around 20-25 minutes or so. And you can actually also see this, how this aerotactic band is forming. I would like to show that to you. So what you now see in the center are two air bubbles. And now look what happens when I'm scrubbing it. So what scrubbing means is I'm now fast forwarding the video. So this has been pre-recorded. So, and look what happens. Can you actually see this ring forming around the air bubble, right? And now the ring is even contracting and moving inwards toward the air bubble. The air bubble backwards again, yeah, so I can actually move forwards and backwards. And you can actually see that the air bubble is expanding. Now that's an artifact. The reason why the air bubble is expanding is because as the water evaporates, it's being pressed flat by the cover glass, so we just ignore that. But more interesting is this ring forming around the air bubble. And not only that, but the ring is also actually moving towards the air bubble. And now here at the very end, you see that there's also air entering from the side here because everything's completely dried up now. But when we go backwards, and there's also a smaller air bubble over here on the left that I would like to show you. So this one over here, it also forms this aerotactic band. So bacteria also start to form there. You might also want to place a look there, and you can actually now see very briefly. Let me stop the video over here. Maybe you're able to see a very fine ring circle around this air bubble here as well. Right, and now the question is, of course, why do the bacteria do that, right? Why do the bacteria form this ring? And obviously, it is because they need oxygen. And like we've seen before over here, we can also see now air bubbles moving in from the side. Those algae, they also produce oxygen by photosynthesis. But the interesting question is now is if the bacteria, if they like air, oxygen rather, why don't they just completely move towards the air bubble or towards those algae? Well, as a matter of fact, over here, ultimately they will move to the completely to the air bubble. So you see over here, now it's actually touching it, right? Very close by. But why don't they do that right from the beginning? And the reason is, and that's also what they found out, is because there is an optimum oxygen concentration. I would like to explain this to you here. You have over here, of course, the highest oxygen concentration is right next to the air bubble, and the oxygen concentration decreases the further away you go. So there's some kind of a diffusion gradient. And bacteria, even though they need oxygen, too much oxygen is bad for them as well. As a matter of fact, oxygen is very reactive, and for some bacteria, oxygen is even poisonous. So what they will do is they will accumulate over here where the oxygen concentration is the best. Now, as the oxygen of the air bubble is used up, there is less and less oxygen present, and that's why they will move actually towards closer towards the air bubble. So that's something that we're able to see over here, right? So now they're barely, it's now touching the air bubble, and then of course everything's completely dried up, and then we've got air bubbles also moving in from the side. So this is something that has been already discovered back in the 19th century by a guy whose name is really difficult to pronounce. He was a microbiologist. Here you can actually see him with his microscope actually kind of shows that you don't need very fancy equipment to see interesting things. And he was a microbiologist, and he actually observed this. Now, it's easy to say for me, well, it's the oxygen, right? Who knows if it's really oxygen? I mean, there are, I don't know, many different substances, but why actually oxygen? Well, of course, we've already seen before from the algae that they produce oxygen, but I mean, how can we be sure? Well, of course, they have done experiments, and it is indeed the case that if you put the microscope slide into different environments with different concentrations of oxygen, then you're actually able to see the movement of this aerotactic band. And they will basically, if you increase the oxygen concentration, then they will move away from the oxygen until they have reached an optimum concentration. And if you put it into a low oxygen environment, then they will move further towards the air. Yeah, and always until they find this middle, the optimum middle, right? Very often, when you do this yourself at home, very often you will find those aerotactic bands not around bubbles, but actually towards the edge of the cover glass. Because then this is obviously where it touches the air, and very often you can also see that those aerotactic bands will actually start to move towards or away from the edge of the cover glass. Very often it's like this, that there are also different regions of oxygen concentration under the microscope slide. So sometimes those aerotactic bands are not completely straight, but they will also go around in the corner, for example, or if there's some debris in there, then this can also distort it a little bit. Basically, dirt and debris that kind of is interfering with the diffusion of the oxygen. Very fascinating in my view. If you want to try this yourself, how can you do that? I'm just going to now show you a little bit my own setup. So this is the water sample that I used. It's a pond water sample. You can see it's a little bit green because of all of the algae, but there's something slimy in there. And as a matter of fact, these are wheat grains, cereal grains, which I basically I crushed between 2 spoons, and I dropped it in there, and then I waited for about a week or 2 weeks. And it's not only going to start to decompose, but it will also start to form a slimy layer around it. And what I've done therefore is I've taken a pipette and I tried to take some of this slimy stuff here, and that's basically what I put under the microscope. We can try it now as well. Yeah, the wheat grain, of course, acts as a food source for the bacteria. So cover glass on top, and now under the microscope. Yes, and here in bright field we can already see that there are plenty of bacteria. They have not yet formed an aerotactic band, so what I have to do is I have to wait now approximately 10 to 20 minutes, and then I'm also able to see that. Well, and in the meantime, we can observe the many water microorganisms that are also present here. For example, here, this is a little rotifer feeling very happy because the bacteria are an important food source. And that's also one of the reasons why those rotifers started to multiply very rapidly in the water sample. Yeah, well, I did not have to wait 20 minutes or so already after 5 minutes. Look, here we already have the bacteria moving into this aerotactic band. You can also see that they're also now moving a little bit towards the top, towards area of higher oxygen concentration. Just want to show it to you again here, that we're not so far away from the edge of the cover glass. Here it is, right? Here, that's the edge of the cover glass. This is where the oxygen comes from, and now they're moving towards it. Yeah, so we're going to just observe them for a couple of minutes, and then when they've reached a certain optimum distance, then they should actually stop moving. Yeah, of course, I also tried it in phase contrast. Now here we can actually see it quite nicely as well. Well, I think that's all from my side, all that I would like to share with you today. I mean, of course, there's a comment section below, so if you've also been successful in repeating this nice little experiment, please leave a comment behind. I wish you all the best. Happy microbe hunting as always, and hope to see you again in the next video. Bye bye.